Hi, fifth graders. Today is lesson 3.3. We spent the last 2 days working on reptiles and learning about how scale factor affects perimeter, area, and side lengths along with angles. Today, you're going to be designing some figures using some constraints that they're going to put on you. But before we're doing that, we're going to start, excuse me, by going through lesson 3.2's solutions. So in question A, they wanted you to make the reptiles of the triangles all triangles. Right, isosceles and scalene have copies that can fit together to make larger similar triangle. One possible sketch is shown below. So they only showed you here one. They wanted you to also know that equilateral triangles also fit together to make large similar triangles. And I think maybe after doing that work, you would think that you would have maybe made that guess that equilateral triangles work as well. For question B1, the trick with the triangles is that one of them does have to be upside down in the middle there. B1 said answers may vary. A lot of you probably did the scale factor of 2 because that would be the first one you would have seen. The scale factor of 2 because each side length is double the length of the corresponding side. And in B2, you answered the perimeter should have been twice the perimeter of the smaller. And in B3, again, the area is 4 times the smaller triangle because four smaller triangles make one bigger triangle. C1 asked you to make it larger again. So in C1, they have figure 1 drawn here below. They did a scale factor of 4. You may have done a scale factor of 3. You can see that scale factor of 3 down here once my mouse moves. If you would have done that one, you can see it there because that would be 9 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you did the scale factor of 3, the side lengths would be 3 times. If you did 4, it would be 4. And in C3, the side lengths are 3 times. The perimeter is 3 times. The area is 9 times. And the angle measures don't change. Again, depending on your scale factor, the side lengths and the perimeter will always be the same as the scale factor. The area will always be the scale factor squared, and the angles won't change. That's true for all similar figures. In question D, you might have had a variety of strategies for subdividing the larger triangle into 4 smaller similar triangles. One possibility for each triangle is to find the midpoints of each and then join the midpoints by drawing straight lines between them. So here's an idea of how you would have done that. If you made midpoints and then connected each one, you would have made similar triangles. And then below there, they show the right triangle and the scalene triangle. In question E1, you would need 25 copies because if the scale factor was 5, 5 squared is 25. E2, you would need 9 because the scale factor is 3. So then 3 times 3 is 9. In E3, it says it is true that all triangles are reptiles. You can subdivide any triangle into 4 congruent triangles, each of which is similar to the larger. You can do this by using that midpoint way that they showed you over here. And if you didn't see that yesterday, that's totally fine. You maybe want to take a minute now to stop the video and make a triangle and see if you can help have that happen. All right, so we're going to move on to 3.3. In 3.3, you are designing under constraints using scale factor and similar shapes. The scale factor from one figure to a similar figure gives you information about how the side lengths, perimeters, and areas are related. In problem 3.3, you will use what you have learned to draw scale drawings. So for questions A and B, you're going to use these 2 figures on the grid. You might use these copy these into your graph paper notebook. If you do not have graph paper, I did post these, and I will post another copy that's just those 2. There's a worksheet here for question A and C. if you want it. And then, like I said, I'll post one that says 3.3a, and that will be those two figures with a blank sheet of graph paper. You could also go back to a previous lesson where I've linked graph paper and just print out a piece of graph paper for yourself. Question A, for each part, draw a rectangle similar to rectangle A that fits the given description. Explain your reasoning. So question A is about the rectangle. The scale factor for the rectangle A to the new rectangle is 2.5. So you start with rectangle A, you apply the scale factor 2.5, draw a new rectangle. Then the next one says the area is 1/4 the area of rectangle A. So you'd have to start by finding the area of rectangle A. What's 1/4 of that? Make the similar triangle. The perimeter is 3 times the perimeter of rectangle A. Okay, so second one is question B. We have the triangle. For each part, draw a triangle that is similar to B given the description. So the area is 16 times that triangle B. So if you know that the area is 16 times, you should be able to work backwards and figure out what the scale factor would be. The scale factor from triangle B to the new triangle is half. So is that going to make that triangle smaller or bigger? Then we have question C, and again, these drawings are on that worksheet down at the bottom here. Rectangles A, B, C, D, and E, F, G are similar. Find the side length of AD and explain how you found it. So make sure that you're using corresponding side lengths. You may notice that one of these is turned, right? The short side needs to match with the short side. The long side needs to match with the long side. Obviously, the angles are the same because these are rectangles. Here it says triangles ABC and DEF are similar. Find the missing side lengths and angle measures. Explain. So again, just tell me how you know that you got the correct answers. What do we know? We may need a refresher here on the angle sum of a triangle. The angle sum of a triangle is 360 degrees, if you haven't gotten to that yet. And then make sure that you're doing the same thing. You're using the correct corresponding sides. They give you two so you can figure out the scale factor, and then use the scale factor to figure out the rest. And that is the lesson. So then you have problems 9 through 18 and 39. You may think, oh my gosh, that sounds like a lot, but look at question 9 through 18. They are not difficult questions. They are not a lot of work, right? So 9 through 14, find the indicated angle, measure, or side length. So for each one, you're finding one piece. Number 15 through 18 is multiple choice, and number 39, you need to find the answers. All right, have a great day.